Okay guys, my name is Habibi. I'm from PLN Institute of Technology Information System. Today in this video, I'm going to walk you through the result of network scanning using InMap. We will look at how InMap detects device on a network, checks open ports, and even guesses the operating system of a target. I will explain everything step by step, so easy to follow. First one, we can go command prompt and IP config. And next, look at this IPv4 address 192.168.18. Next, we can go and map Zinmap. You can type the IP address and slide 24. And you change the scan to ping scan. You can start. Okay, hold on. Okay, first I start with the most basic step, which is identifying which devices are active on the network. For this, I use the command InMap min sn. Is InMap min sn. This type of scan is like asking who's online right now without going too deep, because it doesn't scan port, it only focus on detect active device. From the result, I found around 3 active hosts. We can also see useful information like IP address, response time, and even MAC address, along with the device vendors. For example, one of them is from CTA, which is typically modern or modern. Key point is this only for detect active device, does not scan points, does not scan port, fast and lightweight, good for initial network exploration. Next, we can go to regular port scanning. Okay, this number 2 is a regular scan. After I identify active device, the next step is checking their ports. This is where things start to get more interesting. For example, on the IP address 192.168.18, iPhone port 18 and 443, which are commonly used for web services, and that suggests the device might have a web interface like a router. On, on another device are found port like 135, 139, and 445, which are strongly associated with a Windows system. So at this stage, we can already start making educated guess about the device. Okay, this just for detects open port, identifies running service, and help reveal potential security vulnerability. Next, we can go intent scan. Next, intent scan. I performed a deeper scan using the intent scan option with min A. This allows Nmap to gather much more detailed information. It doesn't just check port, it also tries to detect the operating system, service versions, and even the uptime of the device. In this case, Nmap estimate that the target is running Microsoft Windows based on service like RPC on and NetBIOS. Keep in mind, this is still an estimation, but it's usually quite accurate thanks to fingerprinting techniques. Okay, intent scan is just detect operating system, identify service version, provides detailed system information, and suitable for deeper analysis. Number 4. Okay, number 4. We can go to scanning a mobile device. Intent scan all TCP port. Wait a second. Wait a second. This take a long time. This take a kinda long time. Next, in this section, I focus on a single device and scan all of its TCP port. The result were quite interesting. InMap was able to identify the device as a smartphone, especially an iPhone running iOS 15. It also detected a specific port like 62.78, which is related to iPhone service. This shows that InMap is not just capable of detecting computer of server, but can also recognize different types of device quite accurately. So in the scan TCP port, focus scan on one device, can identify device type and able to distinguish smartphone like iPhone. And next, number 5 and last, you can quick change to comprehensive scan. Can start. Okay, and finally I ran a comprehensive scan, which is the most complete but also the slowest method. This can combine multiple techniques including TCP, UDP, and InMap scripting engine for deeper analysis. What's interesting is that besides providing more detailed information, this can also discover around 24 additional devices that weren't detected earlier. This shows that some devices in a network can remain hidden unless we perform a more thorough scan. Okay, so overall we can conclude that InMap is very powerful tool for network analysis. From simply detect active device to performing deep inspections, it offers a wide range of capability. The key is choosing the right type of scan depending on your needs. Thank you. See you next video. Bye bye. Hello guys, my name is Habibi. I'm from PLN Institute of Technology Information System. Today I will explain my Praktikum 3, and let's go. First, we will open white chart and I choose Wi-Fi. Wait, we should open GMD and type ipconfig, and then we should connect to Google server. Ping 8.8.8.8.8, enter. Alright, next we will open and we go YouTube. We fix to HTTP. Okay. We can type HTTP forever. We open HTTP forever, and yeah, this not secure because we use HTTP instead of HTTPS. The next step was to test connection using ECMP protocol. Type the ping command in command prompt. The test was performed by sending data packets to Google server using the IP address 8.8.8.8. The result show a reply from status indicating that the connection between the client computer and the server was successfully established. Additional, the ipconfig command was used to identify the local IP address to the device, which was 192.168.1.18 on the Wi-Fi adapter. And next, number 3 is HTTP. We can analysis of HTTP and HTTPS. Based on the Praktikum procedure, this test was conducted to observe difference in how protocols capture data and how they adhere to Wireshark. First of all, HTTP testing is not unsecure. The test was conducted by accessing the website httpforever.com through the browser. This website was chosen because it specifically uses the HTTP protocol without encryption. In Whiteshark, when the HTTP filter is applied, packets with the GET method can be observed. Since it is not encrypted, the data within this protocol can be clearly read in the plain text in the packet details panel. HTTPS testing next. This test was conducted by accessing a secure website such as YouTube. YouTube uses the HTTPS protocol, this, and which operates off port 443. In the Whiteshark catcher result, this activity appears TLSV 1.2 or TLSV 1.3. Unlike HTTP, the data in TLC packets is displayed as application data, which is already encrypted. This means the message content or transmitted information cannot be read by external parties. Next, we should go to monitoring all data. This number indicated the sequence of packet capture. Since the start button was pressed, this number continues to increase as more data flows through the network. Next, it was time. Displays the packet capture time in a second, calculated by relatively from the first packet to the last capture packet. Next, this is a source. Shows the IP address of the device sending the data. For example, during a ping test, this column displays the local IP address such as 192.168.1.8. Next, destination shows the destination IP address of the packet when accessing Googling the server IP such as 8.8.8.8 appears here. Next, protocol indicate the communication protocol used by the packet such as TCP, UDP, TLC v1, 2 for HTTPS, HTTP, and ECMP for ping. And next, link display the total size of the capture packet in bytes. This size varies depending on the type of activity and the information carried. Next, info provides a brief description of the packet content. For example, TCP, it might show the port used. And connection status indicator or message if a connection issue occurred. Next, we try to use ECMP filter. To focus the analysis on the ping result performance earlier, the display filter ECMP was used, although the screen might still show other protocols. The main purpose of this filter is to display only Internet Control Message Protocol package. This protocol functions to provide error message and operational information regarding the success or failure of communication with a network. Next, we try HTTP filter. Next monitoring was performed on the HTTP protocol by entering HTTP in the filter field. Based on the capture result, get packet sent from the client to server can be observed. Unlike HTTPS, HTTP packets display information openly, allowing us to view that detailed request data made by application or browser to specific web server. Next, we try to using IP this. This deprecation continue by filtering traffic. Based on the specific IP address using the command IP EDDR 192.168.18, this filter is highly effective for monitoring all incoming and outgoing activities involving a single device. This approach simplifies troubleshooting and allow network technicians and audit communication data for a specific host within a busy network. Next, we can try this. TCP port 80. Nah, 80 filter. The analysis was further refined using the filter TCP port 80 to observe traffic specifically passing the through port 80. This port is the standard port used for unsecure HTTP communication. Through this filter, packet transmission sequence can be monitored, and issues such as TCP retransmission can be detected, often indicated by black color lines in the Wireshark interface. And last, we can try using this filter with TCP flag sign 1. Finally, an analysis of the TCP connection establishment process was conducted by using the filter top flag scene 1. This filter displays scene packets, which are the initial request packets sent by a client when attempting to establish a connection with a server. This process is the first step in the three-way handshake mechanism, which is the standard procedure for establishing a stable bidirectional connection between a client and a server. So, thank you for watching my video. See you in the next video. Bye bye.